Hello everyone. In my last video of arrays in Python, I have discussed what is NumPy, how to install NumPy, and after installation, how to import the NumPy module into our Python program. And after that, I have explained the various different methods to create arrays in the case of Python. And we have seen that there are various different attributes such as array, range. Then we have random and linspace. So many examples I have discussed in my last video related to NumPy. So in this particular video, I'm just going to complete the NumPy module of Python. So just let's start without wasting the time. So first of all, we just have to install NumPy library using command prompt pip space install space NumPy. And once NumPy is installed, we can just simply import it. And as I have explained you in the last video that we used to have the short name of NumPy, that is NP. So we will just use this NP instead of NumPy everywhere. So I'm just discuss indexing in arrays, then slicing in arrays, then some basic operations related with 1D and 2D arrays. And also I will discuss matrix multiplication, transpose of a matrix, how to reverse an array, how to sort an array, and searching, sorting, each and everything related with 1D arrays and 2D arrays I'm going to discuss in this particular video. So just let's start. So just let me create a new array using arange function. Suppose from 1 to 10. So if I'm going to display or print this variable ARR, it is going to return an array of 10 integers from 1 to 10. So now in the case of array, just like strings and list, we can use square braces to index any specific element. So suppose if I want to display the very first element, so array indexes always starts from 0. So we can see array of 0 is going to return me the first element, array of 3 is going to return me the fourth element, and similarly array of 9 is going to return me and the last element, that is 10. And just like strings and the lists, arrays can have negative indexing, and from left to right, indexes starts from 0. And if we talk about from right to left, indexes always starts from -1. So -1 is going to return me the very last element of the array. Similarly, if I want to print the second last element, then I can just use -2. That is, I'm going to start from the right end. So in this way, we can index any specific element, and indexing can be used to retrieve the values. So we just have to remember that from left hand side, arrays index starts from 0, and from right hand side, indexes starts from -1. Similarly, just like we used to have in the case of strings as well as lists in the Python. And suppose if I want to have more than one element to retrieve through indexes, then I can just simply specify the values separated by commas. So it is going to return the elements at index 2, index 4, and index 6. So that means it is going to return 3, 5, and 7. So in this particular way, we can also retrieve the multiple elements of a 1D array using the syntax which I have just explained you. And similarly, if I am having, suppose, any 2D array for which I'm using a variable mat. So let me create np dot arange, suppose 16 elements, and then I'm going to reshape it into 4 comma 4. So mat will be an array from 0 to 15. So indexing can be applied to 2D arrays also, to matrices also. So suppose if I want to see the second element of the second row, then I can just simply pass the value, that is 1 comma 1. So second element of second row is 5. So what it goes. So here indexing always starts from 0. So it is 0, 0, 0, 1, 0, 2, and 0, 3, then 1, 0, 1, 1, 1, 2, and 1, 3. In similar manner, we can just retrieve the values using the indexing. So suppose if I want to have 15, which is the last element, so it is in row number 4. So for row 4, the index will be 3, and for the last element, that is the fourth element, the index will again be 3. So in this manner, you can just simply access any specific element of a 2D array. So this is all about indexing. Moving on to the slicing. So just let me display my original array ARR, this is the 1D array. So slicing is basically used to extract a subsection or a part of the original array. So suppose if I want to have only the first 5 elements of my array. So in this particular case, I will just simply use the syntax 0 colon 5. So it will just give me only the first 5 elements. So how it is working. So as you can see in this particular case, it will start displaying the elements from index number 0, and it will just keep on displaying the elements up to index number 5 minus 1, that is 4. So 0, 1, 2, 3, and 4. So from 1 to 5 the elements will get printed. Similarly, if I am not going to give anything just before the colon, then also it will always assume it as 0, and it will just display the output as according. And if I'm not going to give anything after colon, then it will start displaying the elements from index number 2, which is 3, and it will just display the entire array elements starting from 3. So this is how this column works. And even I can have third parameter, suppose from index number 0 to index number 6, or suppose 7, and with that difference of 2 I'm going to display. So it will start from index number 0, that is element 1, and up to index 6, that is element 7, and it is now going to display with a difference of 2. So 2 will be skipped, 4 will be skipped, and so on. And in this particular manner, it is going to work for us. Similarly, we can just use for a 2D array also. So in the case of 2D array, if I want to extract any specific portion of my matrices, suppose here we are having a 4 by 4 matrix. So if suppose I want to have only these 4 elements, that is 0, 1, and 4, and 5. So what we have to do, we have to use syntax that is from 0 to 2. And for columns, we have to pass the values separately, suppose 0 to 2. So it is going to return me 0, 1, 4, and 5, what exactly I want to have. So what I have did in the case of 2D arrays, we have to pass this syntax which we used in 1D array 2 different times. So the very first is for rows, and after comma what we are writing is for columns. So I'm interested in only first 2 rows and first 2 columns. So as according to it, I have just written the syntax, and it will work as according. And suppose if I want to retrieve the last 4 elements, then what I have to do, so last 4 elements, that means I am talking about row number 3. So it will be denoted by 2 index. And similarly for columns also, I can give 2 colon 4, and it is going to return me the last 4 elements, that is 10, 11, 14, and 15. So it's totally depends upon us what exactly we want to extract as a subsection from the entire matrix. So in this way the slicing is done. Now moving on to some of the basic operations. So just let me go back to 1D array. So this is my array where we have 10 elements from 1 to 10. So if I want to have the sum of array elements, suppose with all the elements should get incremented by 4. So in this particular manner, I can just simply use array name plus 4. So you can see all the elements are 4 is added to each and every element of the array. And suppose if I want to multiply every element of my array with 7, then I can also use the array name into 7. So every element of my original array ARR will get multiplied by 7. Similarly, you can perform subtraction, and you can similarly you can perform division. And let me create two different arrays with the name A and B. So using a range of 4 and B is np dot a range from suppose 4 to 8. So it is also going to have 4 elements. So A is having this content and B is having this content. So both the arrays A and B consists of 4 different elements. Now I can use C equals to A plus B. Now you can see the elements will get added. So element wise operation will be performed. So 0 will get added to 4, 1 and 5 will be added, 2 and 6 will be added, and 3 and 7 will be added. Similarly, I can use another variable D to have B minus A. So in this particular case, you can see 4 minus 0, if I'm going to print it, 4 minus 0 is 4, 5 minus 1 is 4, 6 minus 2 is 4, and even 7 minus 3 is 4. So we can perform basic arithmetic operations on arrays in the case of NumPy, and it will just perform the operations in element wise manner. And let me create two different matrices, suppose 12 elements, and I'm going to reshape it. Suppose 3 comma 4, and then just let me take another variable mat1, which is np dot a range, and suppose I'm going to give 12 numbers starting from 11 up to 23, and then I'm going to reshape it into the same dimension 3 comma 4. So okay, so there is an error. Okay, so mistakenly I have given 13 elements instead of 12 elements. So now if I'm going to print this this is a matrix and another matrix is this. Now I can also use, suppose, add variable to add the elements of mat with mat1, and you will see the elements will get added, and this will be the new 2D matrix with the name add, which I will be having. So in the similar manner, you can perform subtraction, multiplication, and division. And in this case also, the operations are going to be performed element wise. So in this manner, you can just simply try all these things. Now, if I'm going to use, suppose, multiply of mat with multiply of mat with mat1. Now you can see if I'm going to display this variable mul, so it is going to perform multiplication, but again element wise. So if I